August 7, 2025, a paper drops in the monthly notices of the Royal Astronomical Society. Astronomers just measured what could be the largest black hole in cosmic history, 36 billion times the mass of our Sun. And scientists are stunned because it pushes against the theoretical upper limit of what physics says should even exist. And that discovery, massive as it is still smaller than Ton 618. Let that land for a second. Because Ton 618 doesn't just break records. It breaks the rules. It breaks our models. It forces astrophysicists to ask whether everything we thought we knew about how black holes grow is wrong. So today, we're going somewhere no light has returned from in 10.8 billion years. We're going to meet the object that shouldn't exist. The black hole at the edge of the possible. This is Ton 618. It was 1957. At the Tonantzintila Observatory in Mexico, astronomers Braulio Iriarte and Enrique Chavira were cataloging faint objects across the sky. Object number 618 in their list looked like just another unremarkable blue star. Dim, distant, boring. It wasn't. Decades later, when astronomers performed spectroscopic analysis, essentially breaking the object's light apart like a prism to read what it's made of, they found something deeply strange. The emission lines in its spectrum were unusually wide, indicating that gas was traveling at extraordinary speeds, up to 10,500 kilometers per second. That's 3.5% the speed of light. No star does that. What they were actually seeing was the core of an entire galaxy, more than 10 billion light-years away. Ton 618 has a redshift of 2.219, meaning its light traveled approximately 10.8 billion years to reach us, making it a window into the early universe. Vision times. That faint blue dot? It was one of the most violent, energetic events in the history of the cosmos. And we'd been looking at it for decades without knowing. To understand Ton 618, you first need to understand what a quasar is, because most people don't. Imagine a galaxy like our Milky Way. At its center sits a supermassive black hole. Ours is called Sagittarius A, and it's about 4 million solar masses. Now imagine feeding that black hole on a catastrophic scale. Gas and dust pour in, forming a swirling disk of matter called an accretion disk. That disk heats up to tens of thousands of degrees from friction and magnetic collisions. It begins to radiate across every wavelength simultaneously. Radio waves, visible light, X-rays, gamma rays. The result is a quasar, a quasi-stellar object, so bright it outshines the entire galaxy surrounding it. Ton 618's total radiative power is approximately 4 times 10 to the power of 4 watts, equivalent to the combined light of tens of trillions of suns, making it one of the most luminous objects ever known. Vision times. If you dropped Ton 618 at the center of our Milky Way, it would be 23 times brighter than the full moon. It would bleach our night sky into permanent daylight. Every star, every constellation, gone, drowned in quasar light. And that's before you even get to the black hole itself. At the heart of Ton 618's blaze sits an object so massive, physics itself starts to hiccup around it. Ton 618's central black hole has an estimated mass of 66 billion solar masses, higher than the total mass of all the stars in the Milky Way galaxy combined. Its Schwarzschild radius, the radius of the event horizon, is 1,300 astronomical units, or 194 billion kilometers across. That's more than 60 times the distance from Pluto to the Sun. Let's make that human. Our entire solar system, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, all of it, would vanish inside Ton 618's event horizon. And there would still be room to spare. Now here's where it gets even stranger. If you were standing at the event horizon of an ultramassive black hole of this scale, you might not even notice the boundary. The tidal forces at that point can actually be gentler than those of much smaller black holes. You'd cross the point of no return and feel almost nothing, until the singularity, millions of kilometers inward, begins tearing you apart atom by atom. This is one of the most chilling facts in all of physics. The most lethal threshold in the universe might feel like absolutely nothing when you cross it. Here's where Ton 618 stops being just impressive and starts being genuinely troubling to science. Yale University astrophysicist Priyambada Natarajan, the scientist who literally coined the term ultramassive black hole, published research arguing that there exists a theoretical upper limit to black hole mass of around 10 billion solar masses. The argument is elegant. Beyond a certain size, the innermost stable orbit around the black hole becomes so large that an accretion disk can't form efficiently. Feeding slows. Growth stops. Ton 618, at 66 billion solar masses, is potentially 6 times above that theoretical ceiling. And we see it as it existed when the universe was less than 3 billion years old. In cosmic terms, that's a teenager. Galaxies were still assembling. The first stars were burning out. Yet somehow, in that relatively short window, Ton 618's black hole had already eaten its way to 66 billion solar masses. JWST has confirmed that supermassive black holes existed just 500 to 700 million years after the Big Bang, far too massive to have grown from stellar mass seeds through normal accretion. This suggests either a completely different formation pathway, perhaps direct collapse, black holes forming from enormous primordial gas clouds, or that our entire understanding of black hole growth is fundamentally incomplete. The Astro Manual. Ton 618 is the loudest alarm bell ringing in modern astrophysics. There's one more thing about Ton 618 that almost never gets talked about. Surrounding it is a structure so enormous it barely fits into our vocabulary. The radiation levels coming from Ton 618 are so intense that the region is also home to a Lyman-Alpha Blob, a vast cloud of gas surrounding the host galaxy, measuring some 330,000 light-years across. That's more than twice the diameter of the entire Milky Way. BBC Sky at Night magazine. Think about what that means. Ton 618 isn't just a black hole. It's a black hole wrapped in a gas cloud twice the size of our galaxy, which is itself wrapped in a blazing quasar outshining a trillion suns. Layer upon layer of cosmic scale, each one alone enough to be the subject of a documentary. That cloud isn't just decoration, it's evidence. It tells astronomers how much energy Ton 618 pumps into its surrounding environment, how it shapes the gas that would otherwise form stars, how a single black hole can dictate the fate of an entire region of the universe. And now the field is accelerating. In August 2025, a team led by Professor Thomas Collett of the University of Portsmouth published a paper in the monthly notices of the Royal Astronomical Society announcing a new black hole in the cosmic horseshoe galaxy, measured at 36 billion solar masses, close to the theoretical upper limit of what's cosmically possible. They detected it using a groundbreaking combination of gravitational lensing and stellar kinematics, measuring nearby stars moving at close to 400 kilometers per second around the black hole's gravity well. Hampson properties. Professor Collett called it quite possibly the most massive black hole ever discovered, and he immediately acknowledged the uncertainty, because Ton 618 still sits in the conversation. We may be finding that the universe is producing these ultramassive giants more readily than any model predicted. Natarajan, who coined the classification, said it best. I think it tells us that we may want to start looking for more and more of these systems. We're not at the edge of what exists. We're at the edge of what we can see. Here's what I want you to hold on to. Every photon of light we detect from Ton 618 left its source when the universe was just 3 billion years old. Before Earth formed. Before our sun ignited. Before the Milky Way took its current shape. That light has been racing toward us across 8 billion years of expanding space, and we caught it. We caught it with our instruments, our math, our curiosity. Ton 618 is not a warning. It's not a threat. It's a message from the universe's own early childhood, written in fire and gravity across 18 billion light-years of void. And what it says is this: you don't yet know what I'm capable of. Neither do we. But we're asking. And we're listening. If this video blew your mind, smash that subscribe button. Because next week, we're going somewhere even stranger. And trust me, after Ton 618, you thought the universe had shown you its best. It hasn't. Not even close.